what assumptions are we making here, or at least what do we know that we have? And so one of the questions or hints I'll give you is, do we have S or do we have sigma? Sigma, yes, exactly. We have sigma. Why? Because it says we have the population standard deviation. Okay, so for that sample size of 15, are we talking about an average or the mu? Exactly. We have the X bar because that says a recent sampling of 15 pies has shown that the average amount of filling in each pie is 199.2. So if you can just kind of look at these as like clues, like, well, what do I have to work with? And yes, it does require critical thinking, and that's hard sometimes, but you're not going to get it without thinking about it. Now, if we focus on the 200 grams of filling, the dispenser is supposed to dispense 200 grams of filling. So that's the specification for the lot. In that case, are we talking about the X bar or the mu? The mu, exactly. So I'll just kind of draw lines here for you so you can kind of connect the dots here. So we have this is right here, and then let's do red. This one's right here. So each of those letters circled in blue are what we have to work with. And then what you can do is come back to which hypothesis test might we be concerned about. So let's just kind of work from the bottom up. So this last one, mu1 minus mu2, what that's saying is you're going to use that test if you're interested in whether one lot's mean is different from the other one. So in that one, we have two lots that we're working with. So what I'm trying to say is if you see mu1, mu2, that means that you're going to use that test if you have two lots that you're working with. Do we have two lots that we're working with in this case? Heck no. We're talking about one lot of pumpkin pies that we're making, and we're just taking a sample out of that lot. So now let's focus on, of the first two, yes, we're interested in the mu. That's the specification limit. The mu, in this case, is 200 grams. We have to have 200 grams of filling in each pie. So right here, the assumption is that we know the variance, which if you have sigma, then yes, you do have the variance, right? Because it's just a squared sigma. And X is from the normal distribution. So yes, these are two different assumptions. So we're assuming X is from a normal distribution where we can represent the mean with mu and the standard or the variance with mu squared. So now we're trying to figure out, well, both of these look good so far. We just need to figure out which one is best. We're going to use the first one when n is large. We're going to use the other one when n is smaller. So if you're taking a sample size of 50, then it would make more sense to do the z-test.
But this one's a weird one because the sample size is less than 15, but we actually do know the population standard deviation and therefore the population variance. So for this particular one, we're going to go with the z-test.
So see what we did there? We ruled out the other four potential tests by just saying, well, what is n? Do we have two different means? So that's how you accomplish the first couple of steps in the first 5 steps of hypothesis testing. All right.